Virtual reality has been steadily advancing and gaining traction across various industries. VR has made significant advancement in the gaming and entertainment sectors, and they have been main driving force of the development of VR. There is a concept called serious games. Serious games refer to games designed with a primary purpose beyond entertainment. These games are intended to educate, train, inform, or address real-world problems while engaging users in an interactive and enjoyable manner. Serious games can cover a wide range of topics such as education, including safety training and skill development, or healthcare. My name is Haedong Kim, and this is our paper about gamification in education, using VR simulation games and learning behavior modeling to optimize the learning experience. Here, our primary focus is manufacturing education. Rather than using VR as supplementary material for operations of machines or safety, we developed a VR manufacturing game that simulates the entire production cycle of making toy cars with different manufacturing paradigms to teach students these concepts such as mass production or craft production. Other than immersive and interactive environment, there is a unique opportunity that VR provides, which is sensor-based behavior modeling. So VR is equipped with many sensors to track the behavior of users to provide realistic virtual representation and experience. However, this data can be used for learning analytics. Special type of data such as eye tracking or additional physiological signals can be collected, but in this paper, we focus on the one of the most basic and universal type of data, which is are the action, log of actions. We collected the action log from a sample number of students in two completely opposite manufacturing paradigms, craft and mass production. Then we generated the more data based on the pattern. Log data are unstructured data, so to model it, we need to transform them into a mathematical objective. We use dynamic network modeling for that purpose. So we see each student or player as a network, and their actions are nodes or vertices of the network, and we connect these action nodes in the same time frame. So we define sliding time frame window, and as we slide it, we update this network for each player to see that how their action patterns evolve over time. Once we have mathematical objective, the network in this case, now we can do feature engineering. So we use the network centrality feature to to see to investigate the action or behavior patterns of the users, and we define collaborative problem solving scoring mechanism based on this network central feature matrix. And you can find the result in our paper. I want to emphasize that our approach is different from the aggregated the measurement that just test this method is effective or not. But in this case, we can actually investigate the all dynamics between different combinations of users of their CPS scores.